While world leaders are meeting in Cairo for COP27, Egypt has faced yet another summer of soaring temperatures. The heat is causing food insecurity issues in the country. For example, last year, 50% of mango crops were spoiled in the field because of heat waves. Food insecurity is linked also to food loss. And here in the UK, we've seen an increase in food loss as a result of disruptions to supply chains caused by the war in Ukraine. So as global populations increase, climate change applies pressure, disruptions to supply chains increase as a result of the war in Ukraine, and we start to see, or we still have the after effects of the pandemic. How can we start to reduce food waste? It has never been more critical to reduce food waste. So I want to answer that question today. Hello and welcome to Cranfield University's No Time to Waste webinar. My name is William Park and I'm an editor at BBC Future, the science section of bbc.com, where I edit Follow the Food, which is a series we do on agricultural sciences. We've covered everything from precision agriculture to changing consumer behaviours. So I'm particularly interested in this question of food waste. We have three fantastic speakers for you today, but before I introduce them, I'd like to introduce you, the viewer, to the chat function on Zoom. If you have any questions during the webinar, please do ask them in the chat. And we've got about 30 minutes at the end to go through a Q&A, and you'll be able to put those questions to our speakers. We will save all the questions for the end of the webinar though, so each speaker has an opportunity to speak before we go through the Q&A. So that leaves me just finally then to introduce our first speaker, Professor Leon Terry, the Pro Vice Chancellor of Research and Innovation at Cranfield University. He's going to be speaking to us about the global picture. Where do we stand at the moment on food loss? Leon.
Thank you very much, and warm welcome to everybody. Before I start, I'd just like to thank BBSRC, which is one of the research councils, publicly funded research councils of the UK government, for sponsoring this event. So to put my slide up, please. Okay, so my name is Leon Terry. I'm going to give a short presentation just on where we are with food loss and waste, and just how my views on how we might move forward in tackling this problem. So in 2011, the FAO published a seminal report on food loss and waste, which really sort of highlighted the issue, giving numbers around a third of food produced was wasted, and also there have been other reports since then. And indeed, if we look at the Sustainable Development Goals, which have I think are a testament, but because they have held true for the last 20 years, under Sustainable Development Goal 12, 12.3, that essentially says that we should be reducing food loss and waste by 50% by 2030. And I'm afraid to say that this isn't going to happen. And I'll go into the reasons for that and how we might adjust how we tackle this problem. The main issue is around moving the debate from measurement to solutions. So since that FAO report in 2011, there's been a plethora of reports of saying how bad food loss and waste is. Some of the methodology used, in my mind, is questionable. However, there's no denying that this is a serious problem, both from embedded greenhouse gas emissions, the physical loss of food, and the quality loss of food. And I'll talk a little bit later about where some of these losses might occur and how things have changed. But if you look at the methodology that has been used by many, it is questionable. Food loss and waste depends on the commodity in question, the season, genotype, societal changes, where in a time frame food loss is measured. But I really want to move the debate on to solutions about how we tackle this problem. And we can look at this problem, next slide please, we can look at this problem from innovation. So this is an example that was published in the UK Plant Science Research Strategy a year or two ago. And this is just an example of a specific technology developed at Cranfield with industry partners and government to create a solution to scrub out ethylene gas, which is one of the main control factors which we can use to reduce food loss and waste. Now, the specifics of the technology here are not crucial, but what I wanted to highlight is the timeline. So if we look across from the first left-hand column, so this is the technology readiness level. This work started in 2006, looking at TRLs of 1 to 3, and it took about 8 years for that product to really get on in terms of the global scale. The patent was created in 2009, but what I wanted to highlight here is to innovate takes time. It is related to human capital, so people doing the work is the reason why the science can happen. And if we move on to the next slide, please. This is what I really wanted to highlight when we're talking about global food loss and waste and the importance of human capital, that is people, in creating the post-harvest solutions, the research and innovation solutions. So this was a paper that we published a few years ago, but it still holds true. This is where we put forward a multidisciplinary approach to reducing food loss and waste. And I just picked out one of these figures. And this is clearly a map of the world with different colours on. I'll just go through what this means to highlight the point I'm trying to make. So this is a world map showing the 50 most active post-harvest research institutions on the planet. The institutions have been ranked according to their scopus or their publication statistics regarding the first author affiliation from peer-reviewed publications, and these were filtered by the keyword post-harvest and post-harvest related journals. And they were also ranked according to the ISHS International Post-Harvest Symposium presenters. And this is data from 2006 to 2015. And the colours, what they mean here is the dark blue is where there are 5 or more active post-harvest research institutions in that country of question. The lighter blue or turquoise is 3 to 4, and the light blue is 1 to 2. Now, clearly, what this demonstrates is there is a focus around the USA, Southern Europe, and China, and also around South Africa, Brazil, and other parts of Europe. But what is very clear and evident is the lack of post-harvest research institutions in Africa and the subcontinent. And given that that is where most of the growth in the human population is taking place now and is going to continue to take place in the coming years, this is a clear problem, and something really needs to be done about this in order for not only 12.3 to be brought back on track, but us to deal with this problem of reducing food loss and waste within the decades ahead. I wanted to highlight some other compounding problems, and some of my other speakers will touch on this in more depth. Clearly, we have a global energy crisis. Post-harvest losses are dependent on having control over the cool chain, and in many parts of the world this doesn't happen. We also can see the effect of the conflict in Eastern Europe and how this has knock-on effects on other parts of the world, as was stated earlier on. Indeed, if we look at those interconnectivities within the food chain, some of them we can predict and others we cannot. And I think it is incumbent on us as a global community to make sure that we make sure that we continue to invest in not only research on primary production, but also post-harvest research. Indeed, about 95% of all agricultural research budgets are spent on production, and less than 5% are spent on post-harvest research. And I think in order for us to deal with this problem, we have to not only tackle the funding deficit, but most importantly, the deficit in human capital in parts of the world that actually really need it most. Final slide, please. So the UK government has been doing something about this, and I'm presenting this as a model. If you would like to see more, just put that food loss network into your search engine. So this was a network set up by BBSRC, which is said as one of the publicly funded research councils in the UK. It's called the Horticultural Quality and Food Loss Network, and its primary aim was to increase the number of scientists working on post-harvest research within the UK. We've got about 400 members now, and the ethos of what we were trying to do within this network is to try and get, as I would call, mainstream plant scientists to actually consider that there is a space for their research in horticulture and also in reducing food loss. I think that this type of network could be expanded on a global basis so that the post-harvest community can grow. We can start to bring in scientists from primary production and actually interconnect people across the pre-harvest and post-harvest continuum. So with that, I'm going to end. I wish you all the best for the rest of this conference, and I'll pass back to the studio. Thanks very much.
Thank you very much, Leon. Yeah, and that question of how we fill those deficits, the data deficits, with good data, I think it will be something we come back to in the Q&A, where we'll be joined by one of your co-authors, Natalia Fallaghan. And I'd like to remind viewers that you can ask any questions of our speakers in the chat box on Zoom, and we'll come back to them at the end of the webinar. But next, I'd like to introduce our next speaker, Dr. Carol Verheecke-Vaessen, also from Cranfield University, who's going to be talking to us about another problem with food waste, which is food safety.
Yeah, thank you, William. So my name is Carol Verheecke-Vaessen, and I'm a lecturer in applied molecular microbiology at Cranfield. So with no further ado, I'm going to start. So can I have my slides, please? And first of all, what I'm going to focus on during my talk is going to be about the mycotoxin case studies. So first of all, let's introduce a little bit the applied microbiology group, which is a group here based at Cranfield, who aim to have an area of research focused on climate change and mycotoxin, and also reducing food loss as well as food waste in the food chain, with the aim, as Leon was pointing out, to go from measurement but to implementing solutions. So the group is led by Professor Angel Medina Valla, and was previously led by Professor Naresh Magan. And together we look at challenges including the mycotoxin aspect. So why do we focus on mycotoxin primarily? Well, mycotoxin are fungal secondary metabolites that are produced throughout different stages of the food chain, and we go through example just after. And this mycotoxin accumulates and they are thermostable. So a cooking process will not remove those mycotoxins, but might reduce the fungi. But that means that at a later stage, when the consumer is consuming the food, it may be exposed to a certain risk. And so we have developed a portfolio of research that is presented here on that slide, but I will go deep into some examples. So for example, the Oat for the Future project, as well as the Nutrinuts project. And this research is then transcribed back into our own training platform, which is a mycotoxin training hub, where we help the food industry to implement what the outcome of the research we have developed in order to have solution. So first of all, as I was saying, mycotoxin are fungal secondary metabolite. But why do we care particularly about them? Well, in fact, mycotoxins are, as said, toxic for animals and humans. And if we particularly look for humans, you have here highlighted the aflatoxins, which are aflatoxin B1, B2, G1, G2, and M1. And those mycotoxins are carcinogenic for humans. So they have been validated by the International Agency for Research for Cancer as group 1. So there is proof that when you're exposed to those mycotoxins, you can get an hepatocarcinoma, which is a big challenge, and this is why we have drastic maximum limit implemented in the UK, in Europe, and it's also the only mycotoxin that is the most regulated worldwide. So how do we see this mycotoxin into a food loss worldwide context? So here you have an example from the Food and Agriculture Organization about a food chain with different value stages, and you have a percentage of loss depending on the different stages. And we are here giving an example of cereals worldwide. And what you can see is as the box plot are getting to the right, you have more losses. And you have losses that are happening at different stages of the food chain, from pre-harvest, which are also linked with the farm, but then after at harvest stage, at post-harvest stage, that goes also linked with storage, but also transport, traded, process, distribution. So there is losses that are happening all through the stage, from the farm to the end of the process line, and even at the retailer stage. So how do those mycotoxins fit in? What is the percentage of the mycotoxin that lead to those food loss? In fact, this is a very difficult question that we won't be able to answer today. But the indication that we have is that according to recent surveys, I've found out that 25% of all the food that is produced is with a level of mycotoxins that are higher than the European Union or the UK regulation or the Codex Alimentarius limits. So that means that for developed countries that have regulations, complying with the regulation is very important to minimize food loss, because otherwise, if they don't comply with the regulation, this food cannot be sold to humans. But also for the developing countries, that means that if they want to comply to this regulation, they will have a lot of food losses. But at the moment, if they do not comply with the regulation, they are exposed to potential carcinogenic compounds that is, of course, not very good for their health. So if we dig into a little bit more into the context of the whole food safety, mycotoxin, in fact, and these are highlighted here, they are the third hazard that give notification by the rapid alert system for food and feed in Europe. So these systems highlight any challenges that there's been with a hazard, where they don't comply with the regulation that is in place, for example, in the EU. And what you can see is that between 2019 and 2021, mycotoxin was either the second or the third in terms of numbers of notification linked to issues with food safety. And when this notification happens, the food that arrived to the EU borders, or could say also to the UK borders, then has to be destroyed or is considered as a complete food loss because it do not match the requirement in terms of regulation that we need to enter our borders. So there's really an issue with mycotoxin that needs to be tackled if we want to stop food loss. So, okay, mycotoxin, how does it happen? Does mycotoxins are produced as soon as the fungi grow? So if we see that the food is moldy, we just remove it and that's it? No, it's a little bit more complicated than that. In fact, the fungal growth, but also the mycotoxin production, are both triggered under different environmental conditions that we need to understand in order to define mitigation strategies to first minimize those food losses, but also resilience towards climate change. Because indeed, if you look so the availability of water and the temperature have a massive impact on the mycotoxin production, but so does the CO2 level, which is something in a COP27 context is something that is very interesting to have a look at. So now what I'm going to do for the minutes that I have left is that I'm going to give you 3 examples of where we are developing solutions to tackle food safety issues in order to reduce food loss. So first of all, let's focus about an example in terms of pre-harvest. So in the UK, you have the oats production has increased by 60% in the last 10 years. And this production is mainly given for feed. However, there is a premium price that can be given if the quality is good enough to go to food. But the challenge that you have when you're in a such context is that this oat grain can be contaminated with Fusarium lancetiae. And the challenges of Fusarium lancetiae is that these fungi do not produce any symptoms. So don't go in the field and try to find it, you will never find it. But it does produce toxin in concentration enough that could lead to potential health issues. So this is why there is indicative levels put in place in the UK and in the EU to minimize that risk for the consumer. So what can we do to find solutions to minimize that risk? So an example, for example, of what we've been working at Cranfield has been to develop a prediction model. So this prediction model look at the water availability and also look at the temperature, and then create a map on what are the conditions by which, if your food within your process gets to that condition, what is the probability of getting T2 and H2 in your food. This allows then the industry to organize the process in a certain way that they can minimize the risk of T2 and H2. So then after we put the consumer at safety, but also we minimize the food loss with potential non-compliance. And these toxins, now that we have this model, we also need to know, okay, will the risk increase with climate change? So this is also part of the work we've been doing. I'm not going to expand on all the work that's been done, but I would just like to give one example. When we've been looking at how elevated CO2 in the air impact the fungal physiology and how also it may triggers mycotoxins. And if you focus on the red arrows that you can see here, these are pointing out that in fact, if you have slight less water availability for the fungi, but you are at 25 degrees or 30 degrees, that could be linked, for example, to the temperature at harvest time in the UK. When you have elevated CO2, you can have up to 264 times more toxin that is produced than if you were at the current level of CO2 in the air. So there's really a need to consider how the fungi adapt to the situation, because they might trigger even more toxin production. Now that we've looked at pre-harvest, let's look a little bit more towards the supply chain. So another example of work that we've been doing here at Cranfield, and this is really pointing out what Leon was speaking earlier when he was explaining that the research is missing in the African continent. And in this particular case, we've been working with some partners in Ethiopia, and we've particularly been looking at peanuts, because peanut production in Ethiopia has multiplied by 17 in the last 22 years, but it's contaminated with Aspergillus flavus, which produce the carcinogenic mycotoxin aflatoxin. And the level of aflatoxin that you find in this peanut can be 3,000-fold what you will have in the maximum limit in the UK. So there is a need here to help the supply chain to become compliant with the regulation, first to give them the opportunity to export, but also to put the consumers in Ethiopia to safety and to minimize the losses. So what we've been doing is identifying the food chain. So identifying the different step of the supply chain, from pre-harvest to harvest and drying to post-harvest. And for each of these steps, we have identified, and you can see them with the red arrows that are going up, what are the current practices that leads to an increase of aflatoxin in the food chain. Then, based on that, we have been working with our Ethiopian partners to develop conditions where instead of increase, we can either stabilize the mycotoxin content or reduce it. And this information has then been transcribed back into the mycotoxin training hub, where we are training our partners to gain the knowledge that is needed for the food industry, so that in Ethiopia, they can produce a safer food that can lead to less losses and potential exportation for them. I will finally look at one of an example of the work we've been doing here at Cranfield, and I will focus more on the food waste. I will focus more on the consumers, because all of us are consumers here. I think all of us eat bread, but the challenge that you also have is that the fungi adapt to the mitigation techniques or the solution we have already put in place. So at the moment, the bakery production use preservative to minimize the fungal spoilage at your home, for example, if you keep your bread for quite a while. But these spoilage fungi, for example, that are Penicillium or Paecilomyces, they can grow in on your food, and it's usually when you throw away your bread. But this is as a loss. This is food waste at home. So the industry needs to work in order to find a solution so that this waste is delayed, so that you have time to eat all your food before you start throwing it away. But what is very challenging, and this is something we've been working on, is that when some compounds and preservatives are put in place, the fungi can adapt to them. So if we're looking at here on the right, you can see that there is different curves. And if we were in the scenario where the preservatives were working as they were supposed to, you will see that you will only have one curve with the control, and then all the other curves will be flat, because that means that the fungi cannot grow when there is this preservative put at a specific concentration. But what you can see here is that this is not at all what is happening, especially for the preservative on the top, which is casopropionate, where you can see that the fungi grows and is able to grow and create spoilage. So this is also giving us an information that the fungi is also adapting to the techniques that we are developing. So we need a constant evolution and develop solution, and this is what we are doing in the Applied Mycology group. And this is something we need to tackle if we really want to reduce food waste in the food chain. So now we just conclude and take a few take-home message. So I think that it's really important that we identify the critical points to control food safety hazards, because this is the only way that working together we can minimize food losses. Then we need also to understand that we need to adapt to climate change context, but that also the fungi are adapting to climate change context. And then we need initiatives like the Mycotoxin Training Hub, so that we train all together at a worldwide scale to minimize food loss. And this will only be able through funding systems that allow us to have a worldwide scale approach when we collaborated with countries that don't have the resources to develop outstanding research, so that all together we're going to mitigate the food safety challenges. And with this, I'm finishing my presentation and I get back to the studio.
Thank you, Carol. Yeah, and some really quite alarming statistics in there on the prevalence of mycotoxins. I'm sure that's something we can expand on in the Q&A. And I think you made a really good point as well, that we're talking about food waste, and many of us will be familiar with the visible signs of that, like the bread that you pointed out, but much of this is also invisible to consumers too. Thank you. So that just leaves me finally to introduce our last speaker, Professor Toby Peters from the University of Birmingham, who joins us remotely. Toby leads the Africa Centre of Excellence in Sustainable Cooling and Cold Chain. Toby, thank you for joining us.
Thank you, and if I could have my first slide, please. So, thank you. So globally, less than half of the food that requires refrigeration is refrigerated. And this number is particularly low in the developing world, where just 20% is refrigerated compared to 60% in the developed countries. And when you break it down, actually just the lack of refrigeration results in the loss of about 12% of total food production, enough to feed about 1 billion people. Take it down to a country level, and if you look at, say, Rwanda, as an example, food loss equates to 21% of its total land use, 16% of its greenhouse gas emissions, and 12% loss to its annual gross domestic product. So in short, picking up on what we heard earlier, food saved is as important as food produced. And to put this in context further, to ensure food security for all Rwanda by 2050, yields will have to be improved 15 times compared to 2019 levels. But if food loss were to be eliminated, yields would only need to be increased by 9 times to achieve food security. And also, alongside food, let's just not forget 25% of vaccine doses are wasted globally, also due to failures within cold chains. And let's remember on that, more than 1.5 million people globally die from vaccine preventable diseases each year. Next slide, please. At the same time, 4% of global greenhouse gas emissions are caused by cold chain technologies and the lost food. Conventional cooling technologies are highly polluting due to the climate impact of the refrigerants and also the energy use. And in actual fact, cooling accounts for 7% of global greenhouse gas emissions, warming the planet and actually contributing to their own demand. Next slide, please. Low and middle income countries struggle with multiple development challenges: food security, malnutrition, poverty reduction, health, education and equality. All essential within a well-functioning society. But what I argue is achieving these goals will, however, require developing an end-to-end sustainable, resilient cold chain for food and also in pharma. The imperative we face when we think about the impact on the climate is how do we provide the globally connected cold chain for a well-functioning society and in an efficient, affordable, equitable and sustainable manner that builds resilience and delivers against the SDGs, the commitments under Paris, and of course the Kigali Amendment to the Montreal Protocol. Next slide, please. I think the first thing is that there are a number of big challenges. The first one is that cold chain is not cold storage. Temperature-controlled supply chain networks are complex. They require coordination across multiple stakeholders, across countries and between continents. And to date, where donors do engage, they often continue to pour money and effort into the same flawed solutions. More production without addressing loss to market, cold storage buildings that are relatively worthless without the other cold chain links, no technical training, and obsolete technologies often being deployed that lead to loss of emission mitigation opportunities and potentially higher financial costs in the long run. Such solutions are simply unsustainable and not market orientated. In Rwanda, 96% of farmers living in the vicinity of donor-funded cold rooms don't use them. Next slide, please. Additionally, despite the strategic role cold chain plays in delivering key development and climate targets, cold chains are mainly owned and governed by the private sector that often prioritise any produce with better financial returns. They don't think about the impact that could be achieved on the economy, environment, and society as a whole. And the broad range of social benefits from access to sustainable and resilient cold chains are typically treated as a soft win rather than the core driver for provision, and as a result suffer from a lack of long-term investment and a piecemeal approach. Making cold chains part of critical infrastructure is key to breaking millions of rural and urban poor out of poverty and hunger, and improving the ability of food and healthcare systems to absorb economic, environmental and social disturbances to external events such as the pandemics, Russian invasion of Ukraine and other shocks that we see. Next slide, please. Hence, we argue that there needs to be a radical change in the business model where governments quantify the wider social impact of cold chains so as to justify taking a stakeholder role, actively investing in the development as part of their country's critical infrastructure through what we call a public-private community partnership approach. We think this can ensure an inclusive and equitable access to sustainable cold chain, taking into account poor, disadvantaged and marginalised farmers, as well as the communities that they live in. And within this, one major aspect today that is, I think, overlooked is that cold chains are global. For example, here in the UK, we're reliant on imports. 84% of fruits, 47% of our vegetables are imported. Food production will need to increase significantly to feed the expected human population of 9.7 billion by 2050. And this has to be achieved in a warming world. And we need to recognise global cooperation and investment will be key to equitable and inclusive development of the cold chain in low-income countries for our own food resilience. Next slide, please. At the same time, we need to understand the interplay with renewable energy, climate-friendly refrigerants, as well as the impact and opportunities of radical new innovations, refrigeration cycles, the use of drones, blockchain, Internet of Things, as well as the food innovations that we might see, such as alternative proteins, vertical farming, which might dramatically change how we produce, distribute, and consume food. And of course, coming back to vaccines, let's not forget that we're going to see new vaccines, which might require sub-zero cold chains. Next slide, please. So at the Centre for Sustainable Cooling, we're leading a series of national and multinational programs and multi-partner programs looking at the cold chain across UK, EU and internationally. And how do we explore the system solutions, understanding how do we use and mitigate the need for cooling? How do we make, store, move, manage, finance and regulate cooling to meet cold chain needs? How do we facilitate uptake of new innovative solutions at scale, as well as keep increasing awareness among policymakers about the importance of a sustainable, equitable and resilient cold chain system globally that we need? As I said, food saved is as important as food produced. Specifically, if you could jump to the next slide, please, the Africa Centre of Excellence is a first-of-kind centre dedicated to sustainable cooling and cold chain for food and health. And the aim is to see the accelerated deployment of sustainable solutions in Africa, which simultaneously protect the quality and safety, minimise loss, and create and provide equitable value to all stakeholders. The aim is to be the first one-stop provider of state-of-the-art technology and business assistance, training and knowledge transfer along the fork to farm to fork and vaccine manufacturer to arm continua. Next slide, please. The core structure is one centre of excellence in Rwanda, hosted by the University of Rwanda at the Rubirizi campus, Kigali. If you could jump to the next slide, please, where we undertake collaborative research, test new equipment, develop the knowledge and the training programs, which then are complemented and cascaded out to markets through spokes across the continent, where we can showcase how the solutions can be deployed in practical, real-world applications and provide the outreach, learning, training and knowledge transfer. The first of these are being developed in Kenya, Senegal and Lesotho. So as I said, the ACES model is planned to be the flagship of a global network with 2 other centres of excellence already being planned and in development in India, in Hyderabad and Haryana. Next slide, please. At the Verheecke-Vaessen campus, there will be dedicated space to demonstrate technologies and solutions. There will be a fully equipped training centre to support the deployment of fit for market and purpose solutions to meet the needs of underserved communities. We'd have a business hub to provide incubation, training, acceleration support for early stage technology companies and entrepreneurs. And ACES can also provide properly managed and censored facilities to test and demonstrate innovative ideas and solutions. Working within market governments, development agencies, industry, academia, communities and wider stakeholders, the programme has been developed by the University of Birmingham, London South Bank University, Heriot-Watt, the team here at Cranfield and the United Nations Environment Programme, with more than $20 million of seed investment to date committed by the UK and Rwandan governments, with then industry support alongside. The Rwanda government is currently approving the allocation of a further 200 hectares alongside our ACES campus, which will create a single site for the complete logistics chain from soil to fridge. Through ACES and its spokes, we hope that we can support, train and mentor farmer, cooperative and community leaders to build and operationalise resilient and sustainable community cooling hubs to unlock the economic potential. And of course, provide the engineers to install and maintain equipment. Next slide, please. A comprehensive needs assessment for me is the key step to delivering sustainable cold chains. We have to understand and quantify the current and future scale, as well as the nature of the demand for cold chains, identify opportunities that cold chains access can bring, and plan how cold chain development and services accordingly, understand how cold chain demand and provision will evolve. And another element of ACES is we're building a robust, sophisticated, self-organising model, which we can use to populate with a country's data sets to understand and develop and test optimised cold chain for food and health and associated cooling systems to meet government's mission-driven social and economic targets, whilst also mitigating associated greenhouse gas emissions, and also test for resilience against shocks, disturbances and black swan events. And I think this will be a really valuable tool as we look to understand also what a Pan-African cold chain might need to look like for mRNA vaccines. Next slide, please. The other key pillar is, of course, helping business accelerate to market and scale. And so both international companies looking to export, but also local companies from Africa. And so what we can support them is, or will support them with, is access to a properly managed facility to test and demonstrate technologies. We can then identify the skills gaps, and we can provide the incubation space and the in-country delivery strategies. So in summary, we need to take a responsive and future-orientated approach to develop the most cost-effective and equitable pathways with minimum environmental impact, focusing on long-term potential and value. We need to understand how the size and nature of cold chain needs in low and high-income countries will evolve with changes in demographics, climate, food production and consumption patterns, and social norms, technologies and innovations. And as I said, we have to plan for future disruptions to the system, which are likely to happen more frequently. And we have to also define how both ends of the cold chain should operate and coordinate activities to achieve equitable win-win solutions. As said, we need to recognise that developing a sustainable, resilient and equitable global cold chain requires coordination and cooperation among all countries, specifically to address the disconnect between high-income and low-income countries in terms of development. And we need policy and regulations across technologies, food and health that prevent beggar thy neighbour strategies. But I believe if we come together, we can solve this wicked problem. How do we deliver temperature-sensitive market connectivity to achieve global food and health security and resilience in a warming world, whilst economically empowering 500 million smallholder farmers, each reliant on less than 5 acres of land, without using diesel? Thank you very much.
Thank you, Toby. And as Carol and Leon pointed out already, the need for more research on the African continent is great. So the work that you're doing at the centre is clearly very important. Thank you for telling us about it. So at this point, I'd like to open up the floor to questions. We've had plenty come through from you at home joining the webinar, but I would also like to introduce our final speaker, Natalia Balogun, who's joining in place of Leon Terry, who had to leave. And maybe I can come to you first, Natalia, with a question. Leon talked about this need for better quality data, but how do we go about measuring food loss? Clearly, that's a huge issue.
Thank you, Will, and good morning, everyone. Thanks for joining this BBSRC-funded webinar about this topic that I feel is absolutely key that we get together to tackle. So it is a really interesting question. At the moment, my view is that we need to get together and try to measure, quantify, and locate the hotspots for food loss and waste together with industry, academia as a research body, but also government and the wider society. In low-income countries, mostly we find this loss and waste in the early stages of the food supply chain due to a lack of infrastructure, and as Professor Peters was mentioning, lack of cold chain and connectivity. In developed countries or in industrialized countries, we find this more in the later or stages of the food supply chain, more in the retail and consumer. So we do have the technology, we just need to be a little bit more transparent of why we are failing in terms of using and saving the food that has been already produced. So from my perspective, it's an integrated approach, it's a collaborative approach where industry, government, and the wider society need to chip in and be realistic and report where we are wasting and losing our food. This could be to tackle to identify these hotspots and the main points where this is being wasted. But remember that when we are talking about food loss, we are not only talking about the physiological loss, but also the nutritional loss of these key nutrients and compounds that make our lives more healthier. So in that sense is where research needs to chip in and understand the mechanistics behind post-harvest behavior of mainly fruit and vegetables that are the most perishable, and then develop the technology to maintain these nutrients across the supply chain.
Anything
Over
to add?
you, Will.
Thank you, Natalia. Carol, I wondered whether you had anything to add on that. As we were talking about earlier, much of this food loss is invisible to consumers. A very tricky thing for us to even sort of get our heads around. So how do we start to fill in some of those gaps when we're talking about food safety and loss of nutritional quality?
Well, as Natalia was pointing out, I think the first stage would be to have an idea of what is the numbers that we're looking at. And also, I think what is also very important is to get everyone on board. And it's about having the whole chain approach, going to each step of the food chain, sitting down with them, explaining them, training them of what are those food safety challenges that they can achieve, and then develop practices together that fit their needs. Because so often we say, okay, these are the good agricultural practices, just implement them. But that's not the key to the success. The key is to do them with the different partners, work together, develop tailored training programs that can help each part of the food chain to understand what are those challenges that sometimes they cannot see, and then develop techniques and implement the techniques, the solution, right at the door, so that they can then after minimize the food loss through the chain. And I think this would be a key start into reducing those food losses associated with food safety issues.
Yeah, absolutely. And there's this common theme of collaboration required. I wondered whether I could bring in Professor Peters. There's a question actually that's come in from one of our viewers, which is, when will the African Centre of Excellence be fully operational, and how is research collaborations between African countries and the UK going to be supported? And I suppose actually, just to add something to that, collaboration across the entire continent of Africa. Natalia mentioned that a lot of the loss in lower income countries happens pre-harvest and shortly post-harvest, and you know, that's clearly going to be an important thing to address when we're dealing with an entire continent. Sorry, Toby, you're...
Sorry.
Yeah.
Yeah, so I was saying that you know, this is a very urgent problem which we have to solve now. So we're working very hard to get the Centre of Excellence open next year. We're building new facilities, we're installing the technology, and we're confident that we will be providing the training programs both to farmers, but also the engineers who have to install and maintain the equipment from middle of next year and through the spokes, also into a Pan-Africa approach. The thing which is important is that this isn't sort of parachuting in solutions. This is very much being designed and developed as a collaboration between Africa and the UK and wider partners across Europe, in the same way also with India. So, you know, we're looking at understanding what the African market, what the African refrigeration engineers, what they need and what they want, what are the right technologies for them, and then making that connectivity. But at the same time, as I said, you know, this is global, because the cold chain is about the farmer in Africa right the way through to the fridge and the consumer table, you know, in Cranfield, Birmingham or Scotland. So it's about that system, and it's about the collaboration. We also work with, as I said, the United Nations Environment Programme and many others in industry. So it's pulling everybody together to deliver.
Yeah, absolutely. And you mentioned solutions such as vertical farming, or you know, you might add to that saltwater desalination programs and all these sorts of things. You know, some fantastic initiatives, but quite costly. So it is something that's going to require international collaboration to get it to work, right?
Yes, but I think this is the whole point. One of the big things we're doing is actually understanding what is the return on investment. What's the value? Because, you know, saving food along the supply chain is not, obviously you've got the direct value of that, but also it's about, you know, if a country like Rwanda sets targets to reduce stunting, increase economic wealth of its farmers, or, you know, decrease mortality rates, you're not going to do this without food and a cold chain to connect the markets. So what we're looking to do is, yes, this requires a lot of investment, but what we need governments to understand is that this is absolutely critical infrastructure. A cold chain is as important as a road, a water pipe, or an electricity cable. If you can't move the food from farm to market, then you've got serious problems.
Yeah, and I suppose you made the comparison with the pharma industry. You know, this is a problem that's been known for a long time. You know, delivering vaccines, delivering insulin requires a cold chain. So, so it is something that that people have known about, but it's more important now than ever, I guess.
I beg to differ. I actually don't think. I think we've just all been blind to a cold chain. You know, when we had the COVID crisis, and back in, when was it, March 2021, when we were looking at designing a vaccine, and we were looking at the routes to manufacture, no one started thinking about what was the cold chain delivery system at that volume. And I think that, you know, that was in the UK as well as across Africa and everywhere. We haven't ever thought about actually this logistics element to that same extent. As we heard earlier, 95% of investment goes into the production of food. But if you don't have the logistics, then actually, you're wasting 30% or numbers like that of that food which is produced. So you increase production, you increase food loss. And likewise with vaccines, we're not yet thinking about it. I'm seeing mRNA vaccine manufacturing hubs being considered and built across Africa. We're not thinking about how do I deliver a vaccine at -70 or -20 for malaria or these other diseases that we want to address. We've got to do this hand in glove. We've got to develop the logistics chain and think about it at the same time as we develop the production solutions.
Absolutely, yeah, incredibly important. And Carol, I'd like to come to you next. We've had another question in from one of our viewers. You gave some examples of the presence of mycotoxins in things like cereals and nuts, but our viewer wanted to know whether the same applies to fresh produce such as fruit and vegetables. Are they susceptible to mycotoxin contamination?
So yes, they are to some extent. There's some work that's been going on, for example, on tomatoes and Alternaria that can lead to tomatoes. So after, it's going to be also looking at mycotoxin can diffuse inside the food. So for example, if you're looking at a tomato that is going to be rotten or has started to be rotten, some people will just cut the rotten part and then consider that they can still eat the tomato. But in fact, what you can have is that you can have the mycotoxin that in fact is going to diffuse into the tomato, and the tomato itself becomes at risk for you to be exposed to mycotoxins. I will also point out that also the challenge that we have is also dry fruits. So depending on how fruits and vegetables can be dried, so for example, sun-dried, which are sometimes seen as a good quality by the consumers, the drying process can be very long. And during that drying process time, there is a lot of water that is available until you get to the drying stage. That can lead to the fungi that grows on the fruits and produce some mycotoxins. So this can also apply, for example, for spices, for example. So yeah, there is mycotoxin risk in different food chains.
Thank you, Carol. So there's a question here from Chiara O'Brien, which isn't directed to anyone in particular, but perhaps Natalia, you could have a stab at it first, and we can each go around. Industry collaboration in research is a huge advantage for resources and designing implementable solutions. However, on subjects where there might be public mistrust, she gives the example of things like pesticides, chemicals on food, how do we include industry partners without adding to that mistrust?
Thank you, Kira, for these interesting questions. And yeah, I do agree that sometimes some companies carry a reputation that might not align with sustainability or like the type of topics we're talking about here. However, from my perspective, that a company, a big company or a small company tries to give a step towards food loss reduction, more sustainable practices, and a more resilient supply chain, I think is a good step regardless who they are. So society needs to understand, or we as consumers, we all need to understand that the only way forward is collaboration, is cooperation. So even though we might not trust some companies as a consumer, those type of changes, I think they should be seen as good, because they probably are looking at a big piece of the supply chain. And that's where the changes are very critical. So if a big company makes a big change in their policy, I think that should be seen as a good way forward, and should be embraced also by society and support this type of attitudes, this type of changes, because at the moment what we need is radical changes. At the moment, as has been mentioned before by, for example, Professor Terry, it doesn't look like we are going to meet the Sustainable Development Goals set so many years ago. So what we need now is a radical change. We need a paradigm shift in our industry practices, in our supply chains, in our behavior as consumers. So I think every change towards tackling these sustainable development goals and meeting these targets should be embraced, and then maybe we should trust more this type of companies, I would say. That's my personal opinion. Thank you.
That's great. And you mentioned this this need for radical change. And Toby, I wonder whether I could come to you. You know, when you're talking about, and as you said, you know, it's got to work hand in glove with people in Africa to make sure that you're providing the solutions that actually work for them. But a significant change, is it always going to be received welcomely? You're on mute again, Toby. Do you mind?
No, it's not always going to be received just automatically. I mean, we saw this with COVID vaccines. We see this all the time. You know, in Africa, food which is put in the fridge or meat which is put in the fridge can be perceived as that it was refrigerated at the end of its life. So this is why you have to have a systems approach. You have to bring in the consumer, the farmers, and everybody to understand what are their needs, and also make sure that the right solutions are deployed, and you work together to engage and make change. And I don't think that's necessarily, you know, specific to Africa. I think that's, you know, we see that in the UK as well, where you have to take the consumer with you rather than try and impose change. So that's, again, part of our work. A lot of the work of the centre will be to collaborate and develop the solutions which address all of the problems. I mean, that's the problem now, is that you know, if we were just saying, can we deliver cold chain without worrying about the environment, that would set us one set of challenges. It's the fact that we need to deliver these multiple goals and targets at the same time, which add a complexity and mean that we have to work in a collaborative and engaged way rather than simply try and impose something in with a big hammer.
Absolutely. And on the subject of collaboration, and I can open this up for everyone again, there's a question here from Emma Collings. Has Brexit affected the ability of UK-based research collaboration with international communities, particularly considering the complications we have seen with our own import and export abilities? Do I have any volunteers to tackle Brexit? Perhaps I can come to you, Natalia.
That's a tricky one. Thank you, Emma, for your question. So I have seen how the UK has put everything they have to increase the collaboration and open markets because of the needs we have to cover our supply of vitamins. So normally that's covered by fresh produce. So even though we are covered in terms of protein, meat, in terms of fresh produce, that's more complicated. So the UK has invested, or at least that's how I've seen it, invested a lot of funding towards like increasing this type of collaboration, that international reach, to open our markets and understand better how our supply chains and the supply chain in the UK can reach and can be more resilient and also more sustainable. I would also say that there is a shift to more increased local production. So our supply chains are also sustainable with lower food miles, but also more resilience and not so dependable in other countries. So if we have disruptions like, yes, Brexit or COVID-19 or the current geopolitical situation that we are living, we could cover all our nutritional needs in country. But in any case, we need to be realistic from my perspective and acknowledge that our supply chains are international, that we need to rely on other countries as they rely on the UK. And yeah, so keep on working in this line and finding funding through other type of means that we have to diversify and choose other routes that maybe we had before Brexit.
Lovely, thank you. Carol, I wonder whether I could bring you back in. There's a question here from Heather Wixon, who asks, does the emphasis on different staple crops in different parts of the world impact the applicability of current post-harvest solutions? And I guess there's a question there when we were talking about cereals earlier, particularly. We need to diversify the crops that we're harvesting, don't we? So how does your research adapt to that?
Well, in fact, this is a very interesting question. Thank you for asking it, because on the top you have also the fact that a lot of people are switching also to a vegan diet. That is also diversifying the different crops that we are seeing that are growing worldwide. So it is important to understand that although the microorganism will have access to a different level of water and is impacted by the temperature and the CO2 environment, this is really dependent of the crops that we have. So for each and every single crop, we need to understand how the food chain works, and we need to understand what are the post-harvest stages that are critical, where there is potential risk of mycotoxin production. But the solution to implement into the different part of the world and the different food product will be different. So, for example, there is currently in Africa, there is a technique based on biocontrol that is applying a fungi that do not have the capacity to produce mycotoxin at field, and this is leading to a competition with the fungi that is producing toxin and is leading to less mycotoxin. Okay, this is a good opportunity. It's been used in quite a lot of countries at the moment, but it comes also with a potential quality and nutritional loss of the grain. So these solutions can be implemented now, but there is challenges underpinning them. And this is why, depending on the environment you are, depending on the countries you are, depending on your supply chain, how it is, there is specific needs and specific solutions to implement. But some of those are known, but it's just that the collaboration, and I think this is what Toby and Natalia and Leon was pointing out earlier, is that the collaboration between the people that has the knowledge and has the information that is key for the supply chain, and the supply chain that needs this information is the key at the moment, and this is what is missing. And as an example, the work that we did on the project on Nutrinets for peanuts in Ethiopia, we work with the food chain, and the industry partner that we have is pushing forwards because they have a challenge, they know the challenge, and they're sorting out the challenge. So it's really about looking at case by case, but implementing different solutions that some of them are already available, but it's just a matter of transferring back the knowledge into the different supply chains.
Lovely, thank you. And there was a follow-up question actually from Adebayo Abdul Razak, who asks, this sort of expands on what you talked about in your presentation, where do mycotoxins majorly affect crops, especially cereals, at what stage during the process? And I suppose, specifically then, what solutions are there to those particular gaps? So
mycotoxin affect at different stages. So, for example, you have some fungi that produce mycotoxin at during growing season. So you have at harvest, you already have the mycotoxin that are accumulated here. So after is finding the good solution to implement, for example, biocontrol strategies that will that you can implement throughout the crop growing stages, so that when you harvest, you don't already have mycotoxin in your crop. However, when you have harvested the crop, how you handle your crop from harvest to, for example, how you store your cereal for about 11 months in some cases, this is also very important. If your crop is not stored at the right food temperature, you're going to have another kind of fungi that's going to grow in, so for example Aspergillus or Penicillium, and when these fungi grow, they will also produce mycotoxin. So the mycotoxin risk happens at every single stage, as soon as your stage linked to environmental conditions that are suitable for the fungi to grow. So this is why we first identify which are the environmental conditions by which you have the mycotoxin that is produced, and then we can link them with each and every single steps of the supply chain where you might be in those conditions, And this is where you apply solution, or you can apply another process, or you can change how you produce the food so that you put yourself in safety towards these conditions and limit the level of mycotoxin that you have. But as asked, mycotoxin can happen everywhere through the supply chain.
Thank you. And there's a question here from Marta Sanzo, who I think this will come to you, Toby, who was asking about the energy required to power cold chains, and particularly how that can be maintained in rural and disadvantaged areas. But I suppose generally there is currently a crisis with energy, right? And that's going to change some of the calculations, right, when we're talking about the benefits of having a connected network.
Yes, so this for me is the big question, and this is sort of my real area of interest, is the energy strategy. So the problem we have at the moment is when we talk energy, we mean electricity, and when we talk energy storage, we mean batteries. But in actual fact, when you think of it, most of our energy consumption is for thermal loads. In the global north, it's for heating. In the global south, it's for cooling, either for crops or for thermal comfort and air conditioning. So what we actually have to do is start rethinking and thinking thermally. So if I want to drive a cold store or a cold chain when the sun isn't shining, do I charge up a battery, which is an expensive, uses scarce chemical materials, or do I actually make a block of ice and use that to drive the cooling solution overnight? And so this is really the key thing, is that, yes, we can put down solar PV, we can put down many different solutions for generating or capturing energy, but what we need to do is think about how do we store it. And particularly what we're focusing on is using thermal energy storage solutions, and which are focused on delivering cooling on demand at the temperatures required. So this is all part of the strategy, this is all part of the thinking, but we're thinking thermally rather than simply just electrically.
Lovely, thank you very much. Well, unfortunately, we are coming towards the end of our webinar, but there is just enough time for one final comment from each of our speakers. And I wondered whether each of you would be able to think about maybe one final tip or one final piece of advice or consideration for the consumer. You presented a lot of really interesting information here, but what might consumers do to help the global food waste challenge? And I wondered, Natalia, whether I could come to you first.
Thank you, Will. So we have, as you know, a growing population. We need to feed the planet, and as we repeatedly said in this webinar, this is a collaborative approach. So it's up to all of us to be more mindful in our shopping, in the things we grow, where they are sourced, and the way we cook them and keep them at home. So it's just being mindful. As Toby said, food safety is as good as food produced, and that's something we have to keep in mind, not only as a consumer, but in government, academia, and industry. So I can only thank you all for joining today, and also the other speakers. So over to you, Will.
Thank you. Yeah, and Toby, if I come to you next, I suppose particularly in rural communities, the challenge for that last mile distribution in cold chain. There's going to be a great onus on consumers as well, isn't there, to avoid food waste?
Yes, but I think it's also sort of the consumer really needs to engage now with thinking around and helping us think around what does the food system need to look like out to 2050. It's understanding what people are going to be consuming, but also how do they want to consume it, and how will they get their food. So I think it's yes, food saved is as important as food produced, but at the same time, I really hope that the consumer will engage in actually thinking about what does our food system need to look like in 2050, such that it is sustainable and resilient.
Lovely. And Carol, we talked earlier about the challenge of food safety when, for consumers, some of that is invisible to us as well. So what might a consumer be able to do to start to think more proactively about food safety?
Well, I will start by pointing out the link with what Natalia just said. It's about also, you know, being aware of the food you buy, where does it come from, and also like you have recommendations that are usually given in, for example, in the UK, you have the chance to have recommendation on how to use your food. You have dates on until when you can use your food. So be proactive with these. I've seen a lot of cases where people like miss the date and then just throw their food away. And I think this is an easy step that we can start doing by being more proactive and making sure that the food we buy is the food that we need, but also that we use the food by the time that is not available or that starts spoiling. So before that. And I think that for mycotoxin, for some of the countries, so for example in the UK or in the EU, we have regulations. This regulation needs to be discussed. We also need to see how we can fit in this regulation into the current context we are. But in developing countries, I think there is a need also for them to increase perhaps awareness of for example, that a food that seems to be green is that means that you shouldn't be eating it, or you need to be proactive in finding solution because you're exposing yourself to toxic compound. So there is awareness that need to be raised, especially in developing countries where they are not aware that they are putting their health into jeopardy because of eating these food that are heavily contaminated with mycotoxins.
Absolutely. Thank you, Carol. Thank you also, Toby and Natalia. And thank you to Leon, who joined us earlier. And finally, thank you to you for following along at home. I hope you've enjoyed the webinar. This has been No Time to Waste. Until next time, goodbye.